All right, page 2, question number 3. It says, complete the probability area model to represent the sample space of spinning each spinner once, and then answer the questions in spinner number 2. All the results are equally likely. So it's just telling you basically the way it looks is how it is. And then you want to make sure on area models that you're not forgetting any of the like little pieces. So I like to remind my students we are in math, so numbers go inside our area models. Yes, I know in science we put letters, but think math numbers, so numbers have to go inside, but we still do have words on the outside. So we want to, since we already have a box set up for us, we want to fill it in such a way that it fits. So there are 2 here and 3 here, so 2 has to be on this side and 3 has to be on this side. So spinner 1's going to be over here, so I'm going to label this size spinner 1. And I'll show you in a second. I like to label it sideways. So spinner 1, you can label it however you want, but make sure you write spinner 1, and then this is spinner number 2. And notice how I'm like leaving some room here because I need to be writing about the stuff in the spinner. So let me scoot this over a little bit. So in spinner 1, I have 2 colors, red and blue. So you could write out the word red and blue, or it depends on your teacher, but I'm cool with just like R and B. And then this is 90 out of a whole circle is 360. So you can either know that that's 1/4, or if you need a calc, you could do 90 divided by 360, and that will simplify to 1/4. Or you could literally write 90 out of 360, and that's totally appropriate too. Those are equivalent, so it would be okay. But I'm gonna write 1/4. And then the rest would be the rest of this. So 4 minus 1 is 3/4. Okay. And then spinner 2, we know those are all equally likely, so we've got red, blue, and yellow. And it doesn't matter what order the colors are in, just as long as they all get up there. So it could be like yellow, blue, red, doesn't matter. And then I'm gonna write, since they're all equally likely and there's 3, 1/3 for each of them. All right, so then to get the numbers on the inside, it is an area model, so you're actually finding the areas of each of these as they would be rectangles if we actually drew them to scale, but we don't have time for that, so we're not going to. But we're gonna do 1/3 times 1/4 to get the area of this, and we do that for each of them. So just as a reminder, you multiply the numerators to get the top, denominators to get the bottom. I personally like to leave the fractions as they are, and then simplify when I have a final answer, so when I get to this part, because I'll show you at the end what's important. So then 3/4 times 1/3 is this one, so 3/12, and then 1/3 times 1/4 is 1/12. 1/4 times 1/3 again is 1/12. 3/4 times 1/3, slow down, 3/12. This won't always happen where a lot of the stuff are equal, but sometimes it does. 3/4 times 1/3 is 3/12. The reason why, now I can talk about it. The reason why I like to keep these not simplified, because I could simplify this to 1/4, but I like to keep it the way it is because sometimes, and this is one of those times, the denominators will be the same, and then I can easily check to make sure that I've calculated correctly. The way you do that is you can take all of these and add them together, and they should equal one whole, because that will represent the whole sample space of everything happening here. It's like 100% of what's going on if you were to write percents instead. So 1, 2, 3, and then 6, 9, 12 is 12/12, so I'm good to go. Yes, you could do it the other way and simplify and then add, but I think it's just quicker this way. So then it says, given the above situation, find both spinners land on blue. So I want blue, blue, which would be right here. So the answer is 3 out of 12. But then since I'm actually getting to like a final answer, I do want to simplify it to 1/4. Yellow calculators, and other calculators too, but this calculator is like amazing. All you have to do is do 3 divided by 12, push enter, and that thing will literally simplify it for you. It's amazing. But if you have another type of calculator, most of the time you can find a way to get it to simplify for you. You just might need to ask your teacher for help with that. Okay, let's move on. The dreaded tree diagram. At this point, your teacher has already explained to you, you cannot get away from it. I know they're not fun. Maybe you love them. That'd be great. I would be happy for you. But they're not going away, because tree diagrams are useful in other situations because area models, you only get up to 2 things, like 2 spinners. You got nowhere else to put another spinner, so you need that opportunity. As you saw in the game, some of you didn't play that game. Never mind. But so in some of the classes you played a game where you realized like you would have had to find another place to put information you were not able to. It is very long, that game. The tree diagrams we are expecting you to do are not that long. So just understand, we will never ask you to do something crazy like that. That would fill up a whole page. I am giving you about half a page for this, but it's not as bad as you've seen before, possibly. Okay, now that I've rambled, Sally's mother has 2 bags. So these 2 bags of candy are going to represent the 2 separate branches or separate layers of our branches. So it says, but she says that Sally can only have 2 pieces. The first bag has 20 candies with 14 orange and the rest are red. The second bag has 5 orange candies, 25 white candies, and 20 green candies. Sally's eyes are covered and she chooses out of each bag. Use a tree diagram to represent this situation. So just like before, we need titles and then we need to talk about the things. So the 2 things that are happening is she's going into bag 1, or her first bag. And in that bag, she can get, first bag has 20 candies total, orange and red. So we need 2 branches for bag 1. So let's get 2. I kind of like to spread them out. It's up to you. And if you want to write a whole word, do it. If you want to abbreviate and your teacher's cool with it, just write a letter. So then these are not equally likely, but the moment they do look equally likely. So we need to represent their probabilities. So 14 orange out of 20 total. And then the rest are red. So 20 minus 14 is 6, so 6 are red out of 20. So again, you can simplify now if you want, but I personally don't see a point in doing it. You can, it just helps me remember, okay, when I'm checking my work, this plus this is 20, that's 20. But if you wanted to simplify it and then do the work, you can. Okay, now, this is where I see people mess up tree diagrams all the time. The whole point of tree diagrams are to connect things, just like we were connecting 2 different situations here, we're connecting 2 different situations here. So they have to connect. They have to come off each other. So the way you need to think about this is, now bag number 2 is coming up. In bag number 2, I have orange, white, and green. If I get orange in bag 1, I could get orange, white, green. But if I get red in 1, I can still get orange, white, green. So I need 3 coming off of here and 3 coming off of here. So you're getting very repetitive. Unfortunately, in tree diagrams, you have to do that. Area models, you don't, the way it's just the nature of the way they're drawn, but we have to do that. So then we're gonna write orange, white, green on both. So repetitive. All right, so then we need their probabilities because they're not 1/3 likely, they're not equally likely. So 5 orange, 25 white, 20 green. So 5, 25, 20, 5, 25, 20, but we can't just leave them. We have to write probabilities. So 5 plus 25 plus 20 is 30, 40, 50. So 50. For all those. These get to be big, but that's okay. It's not as bad as it looks. So then we need to know a couple things. So it may be different in different classes. I personally only have my students put probabilities on these lines. Sometimes teachers have students put probabilities and then also what the combination of those things are. That could be really useful, but I don't require it, but I will show it to everyone. So here we're gonna do this probability times this probability. So 14 times 5 is the numerator, 70, and then 20 times 50. This is where I love not simplifying because this is all, if you notice, they are all gonna have that same denominator, and then it's very easy to check. So I'm gonna write out 1,000 on all of these, and that's just amazing. I love not simplifying, but then when you get to the end, you want it to be simplified. So then 14 times 25 will give me this one. It's also, you definitely want to have these organized, because when you're answering questions, it can be kind of hard if you're not organizing it. 14 times 20 is 280. Okay, so then 6 times 5 will give me the numerator here. So that's 30. 6 times 25, 150, and then 6 times 20 will give me this one, 120. So then you will maybe be writing also the combinations of things. So orange, 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 white, orange, green. So what I'm doing is orange, orange, wrote it, orange, white, wrote it, orange, green, wrote it, red, orange, red, white, red, green. So when you're answering these questions, it's a lot easier if you have that list over there. So let's make sure that I didn't mess anything up. So to do that, since these denominators are the same, all I have to do is add the numerators. If the denominators were different, what you would do is just add all the fractions together. So that's kind of a pain, but you can just type those in the calc. So we're gonna do 70 plus 350. So I'm just adding these numbers. Plus 280 plus 30 plus 150 plus 120. That does equal 1,000, so that tells me there's not a mistake. If it does not equal, then that tells you need to go back and figure out where you went wrong. It's possible that one of your probabilities here is incorrect, or it's just possible you typed in something in the calculator wrong. So now that we have all the things, what is the probability that you will pick 2 orange? So 2 oranges here, and that would be 70 over 1,000. And then this is where we simplify. And fortunately, we can just type that in the calculator, 70 divided by 1,000, and you can write 7 over 100. Or you can write it as a decimal or a percent. Then the next one, it says, what is the probability that you will pick red, then green? So red first, then green. So red, green is right here, which is 120 over 1,000. So 120 divided by 1,000, see if that simplifies, which it will, to 3 over 25.